Hello, welcome to my talk. I'm Denis Turkov. I'm lead architect in Spryker, and I'm responsible for overall architecture of our applications. Today we will be talking about API, and I will be not talking about API first and headless applications because there are too many of these topics covered. But today we will try to recognize actually what is the trend about building the APIs, how to join our abilities, our implementations together for better results, and not only for better results, but opening new markets. So now I need a next slide, but yeah, fine. So talking about global ecosystem, we usually see this nice graphic here which shows the development of our presentation layers. Basically, we shifted from desktop presentation to more and more granular devices which actually provide consistent user experience. And now you can see that we are going more and more into this IoT direction, and the intersection of IoT devices actually bring the most value. And this graphic it's very cool. It shows the trend, and the trend shows that we will go more and more granular, and the next icon probably there will be no icon because there will be integrations, seamless integrations for devices which you cannot even show as an icon. And this makes it quite interesting for us engineers to actually provide an infrastructure and provide implementation for this. Also, when we have a previous picture from business, we always forget that there is a second part of it, that we need to support all of those devices at the same time. It's not that we just give up on the first devices and we develop new, nice, cool IoT stuff. We also need to support the previous ones, the desktop, the web services, the mobile, the watches, and so on and so on. So you never give up on the previous ones. You cannot just cut your customers, which are already using it, which are already bringing you value, which are already bringing you revenue, and you want to, just because you want to join a new market, not for this sake. Also, when we are talking about the trends, we are talking a lot about omni-channel, and omni-channel becomes a common target for most of IT companies who currently build API or integration or provide new functionalities or new services. And this is quite complicated model actually, if you will look at how it should be built, because it's mostly, most of these graphics, they are just theory, and behind this omni-channel is actually the integration of your touch points into every channel what you already provide. That means that inside your shop, your offline shop, a customer can actually return a product what he just ordered on the e-commerce platform a day or a week ago. Or the same way he can get upsales, cross-sales in the offline market shop point based on recommendations or the data what we got from him while he was buying products via email marketing, via device, via watch, using Alexa skill, and so on. So this actually, it's quite a complicated system, and this requires your data being in one single place, basically the ability to actually have an access to your all data from every touch point. So previously it was not true. You can divide your data sources into separate buckets and then access them separately. Now it's not true. Now you need to have a way and ability to access your data independently from which touch point customer comes to you. Also, talking about communication, you could notice that my talk is actually in English, and this is quite embarrassing. I live for 3 years in Germany, and I don't talk German normally. This actually what brings you an interesting value. You don't learn a new language just because you want to talk to it or you have fun. Sometimes it's also a case, but usually you want to get some more value. You want to understand people. You want to be more interconnected with people, understand what they actually mean. And for this, the same situation happens actually with your API, because talking about old schoolish channels or current channels, you need to talk actually REST or RESTful or RESTish API. You also need to support SOAP and VDSL, because when you are talking about ERP integrations or VMS integrations, you need to actually support those as well. And this is not a joke, because you can be easily disqualified from integration just because you are not able to provide SOAP anymore. Yeah, and also when you want to target new markets, for example, IoT, you want to integrate MQTT protocol for your IoT devices. You want to be able to do so even without stopping your current production system, and do it ongoing. Basically, have your iterations, development iterations, while your production system is up and running, and still reusing the data what you collect from other touch points. So it's quite a good analogy here, that you can imagine that those protocols, those schemas, those standards, they're actually like languages. If you want to go and find the additional value somewhere in between an intersection, you need to learn those. And this is one of points for API, because you need to give to your API ability to learn new formats and new standards. When we are talking about ecosystem, first what you do, you build your own ecosystem. Maybe it's just one channel, maybe it's two channels, maybe it's already omni-channel setup. Doesn't matter, but first you target actually your own infrastructure. You need to provide those data structures, those abilities, functionalities, what your customer require, what brings you actually the most benefit, what brings you money. Once you're done with that, you actually start to provide bridges. You actually start to bridge to other systems, because the other systems, they have their own internal ecosystems, and you want to have access to them. It could be shipment, payments, or it could be OMS or fulfillment or call center, and so on and so on. And each company which provide their own services, they have their own ecosystem you want to actually have access to. And it's really bad when they have no gateway, no way to actually provide you with this data, what you need for your normal and efficient functional. And this is actually quite interesting picture here. It's based on real data, so basically one of these points is probably you, so it just shows how wide and how broad is actually API infrastructure in the world, in the current world, how different companies are actually taking over even some subsets of networks, and probably in one of these groups you can find your company as well, if you are big enough, and or you use AWS, for example. So basically, once you just join this infrastructure, you have access not only for your closest partners, but even to your competitors, because now even competing companies find the biggest value in the intersection market, in the going together, joining power, and building their own value together. So daily challenges in API. These are our challenges we are facing daily. So basically, and this is our, let's say, biggest value and biggest problem. That this is not one point. It's not one item on our roadmap. It's not one item to solve. You cannot find a single silver bullet which will solve all your problems. But you need to tackle one by one. And today, actually, we will be talking about these problems and how we solved it in Spryker, and which approaches are available as well. So basically, these are ways to solve these problems. For example, data control, it should be solved by infrastructure. You should not think for each your resource about the data consistency and data access and permissions. This should be solved on infrastructural level, and we will be talking about this a bit later. Horizontal upgrades. In general, it's actually in all software development, and last year I had a talk about the code quality. You actually need to avoid the monolithic structures, and this is not only about building a cool, fancy modular or microservice setup, but it's just the way how to set your borders inside your teams and how to actually provide them with information that they don't cross their implementations. Painful resource creation, it's another problem that's actually with development, with the fast time to market approach. You need to have very easy way to create resources, to build them on top of your current infrastructure, to build them based on your ORM, on your database, on your Redis or Elasticsearch structures, and just go on without with a prototype. Just without 2 weeks development, you can just launch first prototype and have already worked with them to understand what you really need to develop. So scalability problems is something what you don't want to solve on the way. They should be solved by design. So it's the matter how you prepare your data, how you work with your data, and how you establish your architecture. API vendor versioning, so this we will be talking a bit later. It's quite complicated problem, but you should not provide no vendor version at all. Low code reusability, it's another problem what is used. That's every time you want to build a new resource, you need to actually develop it from scratch. You cannot reuse the existing components or existing pieces of implementations to join a new resource. Also, for documentation, the best way actually to have best documentation is actually to do not have documentation at all, and this solves all problems. And actually, I could finish my talk here, and this will solve all problems. How we tackle it, I will touch a bit later as well. So we're starting with the data control. Data control, it's not something which you can solve. It's not something what you can solve just by your vision or your let's say architecture once. Probably it will develop, but what is interesting and what is important to actually set those questions, to start from the beginning, answer those questions, and understand that there are 3 typical keywords and 3 typical data control entities what you need to tackle. And the first one is ACL. It's basic ACL, where you want to restrict certain resources or group of resources from being accessed by customers with no permission. A second is scopes. Scopes could be used for many reasons, and actually it's quite flexible to approach to solve internal, external data sharing, but it's very handy when you are talking about giving an access to third parties. For example, I'm a customer and I want to I'm registering on a shop system or any service provider, and I have my full access to this system. I understand what I can do. I can create, for example, I can place an order, I can update my cart, I can do this and that. And then someone else from outside, the third party, actually asking me, okay, customer, give me please a part of your data, because I want to manage your data. I want to manage your data flows. I want to manage your interactions with the shop system. Please give me part of your available actions. And a customer should actually understand what he's giving up to, and this typical, let's say, typical interface and typical example is what if you did once an integration with GitHub with another application, you probably saw this little screen where you need to choose which access you actually give to the third-party system. And this is very important because actually you are not responsible for these actions anymore. Third-party system will actually take control, full or partial control on those items. And this is very important to do not to give a customer full awareness and flexibility of this choice. So scopes is a good way to go. Permissions, it's a more granular way, and this is typical. It's not typical for B2C cases probably, but for B2B it's very typical. When you are by contract, you are not allowed to see certain fields. For example, you have an access to a resource, for example, products, but you are not able to see its prices. This is very typical B2B case. And another case, you are not able to see product attributes because they were built or fulfilled by other merchants. It's also possible. And in this case, we are not talking about ACL and scopes, because it's still you have an access to this resource. I can manipulate it. I can have an access to this resource, to this verb. I get it. But now we need to actually filter out this resource Oh, I need to speed up. Really, filter out those data which is not part of your access, and at least these 3 terms, it's not a solution. It's 3 terms you need to really think of on your roadmap and place them as a infrastructural solutions. So that was the previous development process. You could see in past we actually had teams. One team probably developing one product, and this product was had its own cycle. You start from requirements, you go to QA, UQA, and deploy it. You are successful, and then you go another round with the same product. Current development model is changed, and now you have actually 3, 5, 10, 20 teams working in parallel on the same product, and this is actually this changes, it shifts the way how you operate on your applications, because your operations in applications now are on functionality and feature level and not the application level. So they're feature and functionality centric. Then you want to be very fast. You want to release the features fast, and time to market should be very short. And this is another problem that you need to be able to actually avoid merge conflicts between teams, that each team can commit and also release independently from each other. And this is one of those, let's say, engineering management decisions what you need to take on. You need to decide how you do this, how you divide your teams, how you divide your code base. There are no merge conflicts, and there are independent releases possible. In Spryker, we do modularity. We approach this problem with modular architecture, and this allows us actually to scope the functionalities into groups and give teams working on them. Then the releases and changes are independent from each other, but modularity is not the key, it's not the silver bullet, so have a look into other approaches how to solve it. This could be SOA, it could be a monorepo with well-organized code base, bundle organization, for example. It's also possible, but then you need to take care of and control those borders, protect them. You can go nuts and go to microservice architecture, but you need to have quite a level of maturity, because just in the separate talk, there was a big discussion about API versioning, and you don't want to come there when you are not mature enough. So it's a question what you can tackle a bit later. Automating IDE support. So the repetitive structures and repetitive code pieces, they should be automated. You should not generate them manually, because it's error prone. It brings a lot of problems, and we in Spryker we implemented special type of code generators, and Marco had a talk yesterday about this. They called Spryks, and you can use them to automate your code generator and chain them together and bring maximum results. So reduce human error, because all we are humans, we do mistakes, and you need to create automations to make the process of creation simple and cheap, that you do it fast. Then when you are not satisfied with prototype, you just throw it away without a lot of drops on your face. So, maturity of API. This is a bit of theory. I don't want to go a lot in it inside, but there are 4 levels of API maturity. First level, you just approach your API with this one resource, actually, which can do everything, and then under the hood, you need to understand what actually the consumer wants from me and how I can implement this. The second level is establishing the separate URLs, separate resources, to be able to understand which resource I'm talking to, what abilities and information is available for me. The third level, which is level 2 actually, because we are starting from nothing, from level 0, is about CRUD and implementing CRUD by verbs, by using HTTP verbs to understand what part of and what functionality I need to respond to right now. Third level, it's advanced level. It's something what you need to probably refresh and learn in your framework or in your projects, because it's related to hypermedia controls, where you can jump from one resource to another resource by using information from resource. You can navigate previous page, next page. You can also say, I want to have this product, and then the link on attributes will be given. So these are 2 sources what I recommend you to have a look, and Martin Fowler gave a good introduction on this topic, so refresh to understand the level you are. So these are standards what are currently available, let's say. There are much more than on this slide, definitely, and this is usually it's a problem because when you are focused on one format, you are actually completely away from joining another markets, because you actually need to talk different languages, different standards. By default, by the way, we choose the JSON API because it serves on its answers in Spryker. I mean, it answers most of our questions, but I will show it a bit later that actually in Spryker Glue application we allow any kind of standards, any kind of formats to be able to replace them on the way, and I will show you how we do it. So basically there is some formats, probably you will be working with some of them and not a single one, not the only one in your project. So talking about then formats, there are a couple of formats and you need to also think how you will provide the support of them, how you will give an access by JSON XML when your consumer cannot understand your JSON. You actually need to be able to answer with the consumer in the consumer language. So this is Storefront versus Backoffice presentations. Probably one of the biggest discoveries what we did last year, building Spryker API, and here is the problem. When we are talking about customer who wants to buy a product, and also talking about the administrator who is in back office managing your products, you usually think that they both have the same resource, and it looks the same, it smells the same, but there is a bit of flavor which is different. And you can see that even the verb is the same, so they look very, very much similar. But the problem is that when you are talking about the customer, you know the context from where the customer is coming. You can give them the piece of information which is tailored for this exact customer, with his locale, with his currency, with his contract, and so on and so on. You don't need to present all data, all information what is available in back office for your administrator for editing. Basically, this is in case you are building, for example, a native application which is available for your back office administrators to fulfill this information. For them, you need to give actually all information available. You need to give information about locales, about currencies, about all available stores, and so on and so on. So what is not true for the customer. And this separation is actually solves two problems. The first problem is actually the data resolving logic. The data resolving logic is not anymore on the customer side. So basically your application doesn't care anymore how to choose the proper field, because you give only one. And at the same time, it protects the customers from accessing data which is not assigned to them. So now all this what I told before, so standards, formats, and different types of resources squashed together. So basically, and also we want to provide the IDE support with all this complexity, with all this variety of different formats. We want to still support engineers with better IDE, with better and easier implementation. So what we do in Spryker, we actually separated the API application, which in our case called Glue Storefront, and the implementation of exact standard. Exact standard, it's like a library, just you can imagine it and approach it as the Symfony Forms. Symfony Forms is a library which is handy to build your pages, which you just include in your pages because you know that I'm bound to this library at this moment. But your framework is not bound to Symfony Forms at all. It's just the page is bound to a certain library. In this case, we do the same approach, and basically, because you know that this is a module or this resource will be for Storefront for my customers, and also it supports REST API standard, JSON API or any other REST API standard, you can marry them and build actually a module which clearly understands in which context it is and give full support of IDE to developers. So when then engineers look in the code base, they can find that there are support for your terms, for your verbs, for your request response, because in each context, in context of SOAP and REST API, response and request, they are different. They are different objects, but you need to know where in which context you are right now. So the best way to provide this is actually to extract this formatting and other logic outside and marry them just in the implementation. When you come to implementation, you marry them, you get this nicely tailored IDE support where you can see an engineer can actually find all available for REST API methods because we know for which resource we are building right now. right? So if you are building SOAP resource, you will get another support because you can marry another library with this API implementation, and engineers still will understand that currently I'm working in this context, I'm working this representation logic, and I have access to certain fields. So this creates an ability actually to marry other applications and other libraries and formatters under the same resource. Scalability solved by design. So as you know, that cool channels usually tend to scale, and they scale quick. So basically, when the business sees that there is a IoT device which is bringing a lot of money, then actually it will scale. Definitely, they will ask you, please give us more capacity to be able to fulfill the response from customers. So here I want to just tackle a bit of data cache. It's a separate talk in cache in general. The model is super simple. Usually you want to fall back to cache if the data is not is cached, and go to database only in case data is not prepared yet. So it's simple, but the problem is that usually your cache looks like this. That you have all different pieces actually chained under each other. That you just purge piece of this, the one of pieces of parts of the information is purged, and now you need to recalculate the whole objects which are on top of this. And this creates a lot of problems, and main problems are expiration, validation, and purge. What you need to take care of. It's not a not solvable problem, but it's always hard topic. What is bringing you back after you deploy. So advanced resources are not updated properly, you can actually get loose the power of cache. When you just purge a piece of cache which require a calculation of other resources, and you can even have a downtime because you are recalculating your cache yet. So in our case, in Spryker Architecture, you know, we have a relational database and Redis and Elasticsearch separately, and we store all information in database, but then we denormalize it and push in storage and search, basically in Redis and Elasticsearch by default, but they can be switched. So this is incremental asynchronous technology, which pushes your data, denormalized data in the way it will be used in the end, and pushes them into those data instances. So, and no cache. Actually, cache keyword in Spryker is disallowed, and when someone tells cache, then we look at the problem carefully. So vendor versioning, it requires a bit of understanding what does it mean, and usually it means it's very difficult to explain when you're not software vendor, but you become a software vendor just when you have two separate projects. When you in your company you run two separate projects and you want to share some code base, you become a software vendor for your own projects. And this is usually the schema. So software vendor provides some basic implementations for project implement them on top, customize, and then consumer consumes those APIs or implementations. So when we have a document in version 1, which has two fields, integer, and then we have document 2 in next version, which has a new field and also one type is changed. We need to actually understand, is it the BC break in change or not? Because, for example, for vendor, it's a BC break because you need to notify a project. Guys, you need to actually run your database migrations here, yeah? Because you need to bring those fields to your database and they are there. But for a project, it could be not a BC break because project never used these fields, and then project can actually say, even you brought me a new functionality, it's not actually a BC break for me, and that's why you can decide this. In usual setup, vendor actually says what exactly where is the BC break for your API, but this is not true. Only project can define what is the version of your API. So. Reusable resources, that's how usually your resources look like, and that's how we build them in Spryker. So we build resources in Spryker, separate resources which are accessible on their own. We actually build them in the way that you can configure them and chain them together. So it's just by configuration, you can say that images attached to products and images also attached to articles. And this way you can actually say, okay, now I want to get my products, include images. Okay, so, and when you go a little bit crazy with this, you can actually model your system in the way and configure your system in the way that you have access, please give me products with images and also articles which are attached to these images and also categories of these articles. Boom, only with one request. And this is also important that this is one request. It's not that you need to do like 50 requests to get all this information. It's one request which includes. So this way, actually, REST API becomes more GraphQL-ish. So it's a very interesting side effect that actually when you build REST API now, you have full flexibility of ACL, of good versioning, of permissions and scopes, but also you remove the also you have ability to change resources as in GraphQL. So this is pretty cool concept. API documentation. So base documentation which does not exist, and actually how we solve it, we solved it in the following way. Basically, we decided to do not introduce documentation at all, but build it on the way. So when you have your project up and running, basically when you are building your project on your dev machine, you can run a command which will pre-generate your documentation, which can be easily imported into Swagger, because it's a Swagger prepared, Swagger ready format. And then you have an access actually to fully furnished documentation, which is based on the code base. And the thing is that code base doesn't lie. What is in your code base, it's exactly the implementation, what the consumers want to see, want to understand what types are provided, what chains are provided, how you can include, what are the code statuses, response code statuses available. And this is all baked, there is no lie in it. And this is the main idea, that there is no documentation, because you should not build and maintain it on the way. You should not change your documents when you update your code base. So that's why it's never outdated, it's always aligned with behavior. It's the same format for owners and consumers. So you as developer, you have the same format, the same understanding of your API as your consumer. So basically you have the same point of view, and it makes its creation much, much easier. And this reflects project configuration, basically, because you can say, okay, this resource is available for you, but without this field, and then it will be reflected in documentation as well. So based on configuration, also on chains of your resources. In our case, because in Spryker you can chain resources with REST API, and you can know what is available for you. So it's Swagger and Postman ready. So you just install it, you build this documentation, and it becomes available immediately. I recommend for all projects actually to have a look into this, basically to remove the documentation topic at all, that you document by your code, by your names of your methods, by the structure of your code, by the names of your models, and this should be part of your documentation. You just transform it in the way that is can be read in a more comfortable way, yeah, that you don't read code, you read aggregated information, but that it reflects the truth, it reflects the current state of our code base, it's not detached. And Swagger and Postman, they are widely used. That's why I recommend to have a look at them as well. So I think it was quite a short talk to actually introduce all solutions what we have in Spryker. But I wanted to just focus on a couple of parts you need to take a look in your project. So first of all, many of you actually struggling with API. It's not, you are not alone. You are not alone who is building VDSL or crazy SOAP integration. Still you are running REST API. It's not, you are not alone. Everybody has this, because when you want to integrate an old ERP system, this always a topic. Even we want to think of that we are already far away and we lost those mastodons, but they are still there. So we need to have it, otherwise you are disqualified. So have a look into. I also recommend you to have a look at our implementation, because we already solved them, and you, even when you don't use Spryker system, but still it's a good foundation, because we have open code. We publish it all the time, and we share our knowledge, our expertise with other engineers. So avoid monolithic structures. This is the matter how you structure your teams and how you structure your code bases. So in general, you just have to provide an ability for parallel development and independent releases. That will be all what you need to think about on this monolithic, because other problems will be solved on the way, basically. I mean, automatically. When you solve a monolith problem, then other problems such as upgrades, such as legacy, will be more diverse. You can understand them in a more precise domain object way. So prepare for scale by design. So they just put in the very basic infrastructure of your system parts which will allow you to scale fast in future. Even today you have 10 requests per minute, but tomorrow you will have 81,000 requests per minute, and your business will not understand if you cannot support this, because they will be able to give you money. But if infrastructure and architecture is not ready for this, no money can help you. You need like months development to actually change completely change your data structure and the way you build in your application. So prepare for scale by design. It's another point, and break documentation in the code base. It's in general. This topic it is not relevant only for API, but API is crucial, because when API documentation is outdated, your consumers, they are not happy. So when you lie about your types or not availability of certain fields, the consumers cannot develop their business value to your system, and with this you lose money exponentially, because when all integrations cannot understand how to deal with your API, then you lose direct money from this inter-company communication, inter-company bridging, and additional value what you could add on top. So, in the end, I wanted to say that some of you already build an API, some of you planning, because all of us actually, we want to be a point on this big map with all these AVS and other shop systems running, because world will become more and more intersected, and more values will be found in between of companies, in between of technologies, in between of markets, and we will all pass this way. It's just it's much better if we can expect from each other let's say mature level and mature approach in APIs that we can work with each other. Yeah. So yeah, in the end, I want to ask you, please provide best API what you can. Please integrate with others. Please join the market. Please join the global ecosystem and build API we all happy to work with. Thank you. Okay, now it's Q&A session. If you have any questions, I'm happy to answer. Yes. Mm-hmm. So first of all, I want to say that Spryker by default is not microservice based. It's modular based. That actually allows you to create services, independent services in the system. But internally we don't do it. I mean, we don't provide the out-of-the-box microservices. There are abilities to build such, but it's not out of the box. It's just one assumption what I want to put on site. Another thing is it's more that's data control. It's relevant for your customers and third parties actually asking your questions, asking your system. And internally, you should reduce any kind of permissions, any kind of additional execution flows to reduce actually internal communication, because inside the system, when you already pass the gateway, then it's too late to check permissions. So basically, at this time, you already need to navigate and trust. Otherwise, you will lose exactly what you said. You will lose in performance a lot, because it's actually multiplied with a number of chains you need to pass through to get actually the required data. So in our case, we also we do squashing those. So basically, we do, for example, when you request a product, you can get actually all included information together via joins, via get multi, with in Redis, and we don't chain them one after another. We do it in one shot. So, and this removes the problem from the table. So your internal systems should not have this data control, because it's first of all built for external systems talking to your system. Okay. Any other questions from our product team? Maybe how we build it all. Right. Okay. Then thank you very much and have a good day.